Good morning, children. Today we are going to see the periodic table. What is this periodic table? We know there are so many elements available in our atmosphere or on earth. Okay, we cannot remember all the valencies, the symbols, all that. So we are going to arrange them in a easy manner so that we can easily remember or we can easily understand the properties. Okay, so Dmitry Mendeleev only formed this periodic table which we are following. There is a huge history for this periodic table which you will be learning in your next year, in your 8th standard. As of now, we are going to see how this Mendeleev periodic table is being arranged. So, the Mendeleev periodic table is the first calculation which accommodated the available elements. That is, with the available elements, it was arranged successfully. Okay, it was limited to 63 elements in that time. But now we are having 108 elements. The modern periodic classification has periodic classification table is having 108 elements. But when Mendeleev created this table, there were only 63 elements. And he arranged those elements in the periodic table. Okay, so how he is written? See, the modern classification is applicable for 118. Sorry, I told 108. There are now 118 elements. And these arrangements are based on the atomic number. This is very, very important. These two data are very, very important. Okay, the elements are arranged in the horizontal rows are called periods. So the rows are called periods and the vertical columns are called groups. Okay. And there are 7 periods and 18 groups. See, we will see this. So, this is the periodic table. Okay, this is the periodic table. First one is, see, first is how many periods. So, these are all the periods. 1, 2, 3, 4, 5, 6, 7. Okay, we are not bothered about this. Why? I will tell you. 7 periods. And then how many columns we will be having? We will be having 7 periods. So periods are the rows. So 1, 2, 3, 4, 5, 6, 7. So 7 rows. How many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is it not? 18 columns. So 18 columns. You can write it in here and keep 7 rows and 18 columns. 7 rows. Rows are called as periods. Okay. And the columns are called as our groups. This much is very, very important. You should be very, very thorough. 7 rows and 18 columns. Okay. After that, all the elements will be showing a regular graduation in the physical and chemical reactivity. So, physical properties and chemical reactivities. That is, slowly they will be showing gradual. If carbon is here, it will show slow reaction. Silicon will show a little bit high. Germanium will show a little bit. So, if they are in the same group, these are all called groups. In the group, they will be showing slight variations in their chemical reactivity, but in the physical properties, all the properties will be the same. Okay, and in the period wise, from here to here, there will be obviously there will be a gradual increase or decrease in the properties. It will be either increasing or decreasing in the given properties. Okay, when it is moving from left to right, there will be a sure change, but when it is moving from top to bottom, there will be only slight variation, very, very slight variations. Okay, that much you should know. And here they have given the color code. See, this violet color is called alkali metals, and this pink color is called alkaline earth metals. These are all available on earth. Magnesium, calcium, okay. Then strontium, barium, radium. These are all available on the earth surface. So they are called as alkaline earth metals. Then this yellow color things are called transition metals. These are totally available only on some transitions based on some chemical reactions. And this green color is called poor metals. Aluminium, gallium, indium, these are all called poor metals, this light green stuff. Coming to the dark one, the dark one are called metalloids. Metalloids, we know the things which show the properties of both metals and non-metals. Okay, then this light green color are called other non-metals, that is these are the non-metals. So the variation is see from the light green to the poor metals to the non-metals, you will be having the metalloids. And this pink color, this blue color, the first blue color are called halogens, and in the last blue color is called as noble gases. This dark blue color is called noble gases, and this is called halogens. Okay, and this orange and red, orangish and red color are called actinides and the lanthanides. Actinides and the lanthanides. This is totally available only in the lab, these two sections. Okay, this totally available only in the lab, and this is poor metals. This green color is called the metalloids. These are all the non-metals. This is totally halogens, and the last column is called the total rare gases or the noble gases. Okay, now coming to the correlation of the valency and the group number. Okay, we can say the valency with the group number itself. Okay, the number of shells, we know what is valency. The number of shells and the number of electrons in the outermost will give me the valency. Okay, so the number of shells will decide the number, period number, and the number of valence electrons will decide the group number. Okay, so the period number is based on the shells, and the number of valence electrons will be giving the group number, period number and group number. Period number is based on the shells, and the group number is based on the valence electrons. Okay, so this much you should know, and then that is how we are placing the element. See, for the boron, how many valence electrons are there? 3 valence electrons, so it is placed in the group number 3. Coming to the aluminium, number of valence electrons is 3, so the group number is 3. So based on the group number you can say the valencies also. Based on the group numbers you can say the valencies also. Okay, so based on the group number, say boron is in the 3rd group, so how many valence electrons? So this all this will have valencies 3. Carbon valencies all will be 4. For nitrogen it will be 5. For oxygen it is 6. But valency is not 6. Why? You are going to move to the end. So it will be, the moment it crosses 5, it will take the electrons. So it will be wanting more electrons. So it will be wanting 2 more electrons to become 8. So the valencies will be shifting. So after this the negativity will be more, so it will change into anions, so it will be taking more electrons. So 2 more electrons if it will become noble gas, so that is 8. So 2, so this is valency is 2. For fluorine, chlorine and this halogens also, if it take 1 more electron it will become 8. This noble gas means it will be having 8 electrons, 8 except helium. From neon to this one, radon, all this will be having 8 electrons in their outermost shell. So this is totally stable. Here it will be having 7. So it will having 1 more. It will be wanting 1 to become 8. So this is all valency 1. Here valency will be 2. Here it will be either 3 or 5. That is why phosphorus is having 2 valencies, either 3 or 5. For carbon, this is in the stable thing, so it will be wanting 4, so it is 4 only. For boron, it is 3. It will want to give away 3. Don't want 5. Okay, so all this will be in 3. And then coming to here this is beryllium, magnesium. This is all will be 2, and in lithium it is all will be 1. Okay, so these are all the valencies you should know from the groups. Okay, that is what they have discussed here. And the number of valence electrons will be increasing in a period from left to right. The number of valence electrons will be increasing. That is enough. So in the group 1 elements, okay, you can say all the valency is 1. So they are all monovalent. You need not write all this. The first line, group 1 elements having their valency 1. So they are monovalent. Likewise, group 7 elements, okay, they want one more electron. So they are also monovalent. You can write this. Okay. Then coming to group 6 elements, the valency is 2 because they want 2 more electrons to combine or to form 8 electrons. So the valency is 2, so they become divalent. Okay, then group 5, that is our boron group, that wants 3. So it can be 3 electrons, so it is becoming trivalent. This much is enough. So in the modern periodic table, we will be having 118 elements and they are all based upon their atomic number. Next, there are 7 periods and 18 groups. Periods are the rows and groups are the columns. Okay. Now, depending upon the number of shells, you have the period number, and depending upon the number of valence electrons, you have the group number. Okay. If there are number of electrons as 1, that means the valency is 1. Okay. That means it will be placed on the first group. So this lithium, all these are placed in the first group. And if there are 2 electrons in the outermost shell, say in the case of calcium, okay, then they are placed in the second group. Similarly, in the boron, and then you will be having carbon, boron, carbon, nitrogen, oxygen. So oxygen, there are 6 electrons in the outermost shell. So they are placed in the 6th group, but the valency is 2. It is not 6. Why? Because if it gains 2 more electrons, it will become the stable. That is, the outermost shell will become stable, or the atom itself will become stable. So the valency is 2, but it is placed in the 6th column or the 6th group. Okay, so you have to be very careful. And then how they have written on the periodic table. The top is written as atomic number. Then they are writing the element name. Then the symbol for the element and the mass number. This mass is the weight of proton plus neutron. Here it is the number of electrons or protons. This is or. Here plus. So proton plus neutron will give the mass. Atomic number is either the number of electrons, which is also equal to the number of protons. We already know, because the number of electrons will always be equal to number of protons. Okay, so this is how every element will be written. First atomic number, then the name of the element, then you should know what is the symbol, and then you should have the mass. Okay, so this is how the periodic table of the elements are written. Okay, now we will see the exercises. The nucleus of the atom will contain neutron and proton. Okay, the triatomic element here is ozone. Triatomic, at least 3 atoms are combined. You can take ozone as the example. Then which of the following is a divalent? Magnesium, because it is only having the valency 2. The valency of the oxygen is 2. Then coming to the which of the following elements show variable valency? Nickel. Sodium, carbon, helium all will have only single valency. Only nickel will be having other valency. Then the negative radical from the following here is hydroxide. This is OH minus. Other are all aluminum. This is 3 plus. Magnesium is also Mg. 2 plus. Ammonium is NH. Ammonium. It is not ammonia. So this is NH4. Okay. Now coming to the fill in the blanks. A substance that contains only one kind of atoms is called element. Subatomic particles with negative charge are called electrons. Then the element phosphorus is called tetraatomic. Okay. Then atom with negative charge is called anion. The elements are arranged in the horizontal rows are called periods. Vertical columns are called groups. Horizontal rows are called periods. Coming to the true or false. Neutrons do not have any change. True. Chlorine is a divalent element. No. False. Copper exhibits variable valency. True. Cations are with positive charge. True. Ionic bond, two atoms share electrons. False. Okay. Then this define, this differentiate, all I have given. Learn from there. I will be giving you the detailed question answers. Okay. In this week I will send you the PDF with the detailed question answers. Okay. In the next class, we will see the detail and the definition and differentiate of all these lessons for our second summative. Okay, children? Thank you.